Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I hope all of you are doing fine and staying safe. Our today's topic is going to be wireless transmission media. In my previous lecture, the first half of this lecture actually, we studied about transmission media. What are the different transmission media available to us? We talked about the twisted pair cable, the benefits and drawbacks of coaxial cable as well, and then we talked about the fiber optic. We also looked into the factors that we need to consider when we are trying to choose a transmission medium. As all of you experience in your daily routine, we have actually moved to wireless connectivity a lot more than the wired transmission media. So, in today's lecture, we are going to explore the possibilities of wireless transmission media. In the wireless transmission medium, we have the radio waves, the microwave, or the infrared. All of these are example of electromagnetic radiation, and the only difference is that they operate on different frequency bands. First, we are going to talk a little about the radio waves. Radio waves operate in 3 kilohertz to 300 gigahertz frequency band. It's omnidirectional. Omnidirectional means you cannot direct radio waves in a specific direction. The radio waves will start transmitting in all the direction at once. And it actually can bounce back off of any surface that it touches. This can be a depiction of a radio waves antenna. As you can see, the diagram also suggests that the transmission of radio waves is spreading in all directions. Then we have microwaves. Microwaves are a lot focused than the radio waves. The frequency is between 1 and 300 gigahertz. And it is used for the unicast. Since it can be focused into one direction, it is used for the unicast communication such as cellular phone satellites or uh, uh, networking and the wireless Wi-Fi routers that you have to have the wireless internet connectivity at your home. Most of these devices are using microwaves. Then we have infrared. Infrared has a frequency between 300 gigahertz to 400 terahertz. It has low penetration and it is used for the short range communication in a closed area because the higher frequency makes it unsuitable to be used on longer distances. This is actually an example of comparison. This is taken from this diagram, particularly is taken from your course book. When you're selecting the wireless transmission medium, these are the factors we need to focus on. The bandwidth and data rate, as you can see from going from right to left, infrared can accommodate the largest of bandwidths. Attenuation means the loss of signal. We discussed this concept in the previous lecture as well. The attenuation means that the loss of signal being fading out, is a lot more in infrared and a lot less in the radio. Need for repeater is less for radio and more for the infrared. Then directional focusing capability means targeted communication means you can throw these wireless transmission mediums into one direction and they will get message to that direction particularly on target. Infrared has more directional capabilities. And penetration through walls is higher for the radio waves and quite less for the infrared. For the interference, constructive or destructive interference, there is no symmetric trend. Different waves behave differently in different circumstances. So we cannot develop a pattern of interference when it comes to the radio or microwaves or the infrared waves. So based on this comparison, if we have shorter range network and we want more data rate, we would select infrared. And if we have a longer range network, we might go for microwave, and for a range even longer, we might use radio waves. When we compare these, the drawbacks and advantages of cable and wireless transmission mediums, we first need to understand that there are certain frequencies that are reserved. For example, you have seen police department using the wireless communicators, walkie-talkies. The frequency that they operate on is reserved only for them. We cannot actually use that frequency. And then there are some paid frequencies as well, which are the higher frequency bands, which are actually bought and sold by the telecommunication companies. Outside that range, all the frequencies are free, and we can operate on those frequencies uh, free of charge. And then for the cable, to lay the cable, we need the permission of the landowners. Otherwise, for wireless, we don't need permission of anyone. If we are operating on an open frequency, we don't need permission from anyone. For a large scale communication, we have two technologies. One is fiber optic and the other is the satellite communication. Right now, both of them are competing almost equally with each other. We have the same amount of traffic through fiber optics and almost same amount of traffic from the satellites as well. There is no dominant technology. Fiber optics, as you can see, laid through the marine cables, through the oceans, connecting the continents, and there are a lot of communication satellites up in the Earth's orbit as well. And both of these mediums carrying a lot of uh, volume of the internet traffic. When we are using a wired medium, we will not face a lot of interference. But for the wireless communication, interference is going to be much more significant. So, and probably we are unable to find good frequencies for our communication as well. As compared to the wired and wireless communication, we need less repeater for the wireless communication. But for that point, you already know that it is based on what kind of waves you are selecting, what kind of transmission medium you are selecting. For the cell phone towers, you are only using the wireless transmission, and they are not dependent on the wired communication. So the wireless is dominating the cell phone industry as well. And wireless network is quite handy, quite uh, suitable for the small office or home environment as well. You might remember the lectures of networking topologies, and you might also remember that we have to lay a lot of cables in order to get connected with a network of any of those topologies. But for a wireless network, we just have to have a Wi-Fi enabled central networking device, and we don't have to deal with any mess of cables at all. The maintenance of the network is quite easy. The addition of the newer devices to the network is piece of cake. You can very easily block anyone from your network as well. So wireless networking is much more suitable than wired networking when it comes to the smaller networks of homes and offices, because it actually makes your life a lot easier, gets rid of a lot of headaches, as I have mentioned. Next comes the topic of satellites. Up till now, we have discussed in a limited scenario. Satellites actually gives us global connectivity. Satellites operate in three layers. There are three types of satellites. There are low Earth orbit satellites, there are medium Earth orbit satellite, and there are this layer that you are looking at, the Van Allen belt, is actually the region above our Earth filled with the uh, solar particles. Satellites operate in this area. When we talk about the low Earth orbit satellites or LEOs, they can complete the orbit around Earth in almost 90 minutes, but they cover less area. We need 50 of the LEO satellites to cover the complete globe. And most of your cell phone communication actually depends on these kind of uh, low Earth orbit satellites. The communication satellites actually usually are the low Earth orbit satellites. Then we have our medium Earth orbit satellites or MEOs that operate from 3,000 to 30,000 kilometers. The GPS global positioning system that all of us almost daily use for mapping, traveling, location sharing, actually it is using the medium Earth orbit satellites. And since they cover a lot more ground, only 10 satellites are needed for the whole global coverage. Then we have geostationary satellites, which is also called GEO. We call them geostationary because they are in the geosynchronous orbit with the Earth. Means if we look at a geosatellites from Earth, it will appear stationary to us because it is moving in synchronous motion with the speed of Earth. So it always remain on top of the same point on Earth uh, where it is launched, where it is placed. Sorry. They can complete their rotation in almost 20 hours, and only three of these satellites can cover the whole globe. Their altitude is usually 30 to 40,000 kilometers, so they cover a lot more area. Only three satellites are needed to cover the whole world. They are mainly used for the weather observation, the atmospheric tracking, the ocean mapping, and communications as well. And this is our last and I think costlier of all the transmission medium. So this is where we are going to end our discussion of the transmission mediums. Uh, there will be a worksheet coming your way through the Google Classroom. I would hope that you solve and submit it by the end of the day, Friday. And now we'll move to the question answer sessions. See you again in the next lecture. Allah Hafiz.